This video will discuss chapter 12.8, similar solids. So we're going to start by looking at two cylinders and trying to determine if these two cylinders are similar. And so what we want to do is set up a ratio. So a bunch of different ways that you can set up the ratio. This is the radius of the base, right? And then this is the height of the cylinder. So one way that you could set this up is to say the radius of the smaller cylinder over the radius of the larger cylinder equals the height of the smaller cylinder over the height of the larger cylinder. Okay? Another way, let's write this in a different color, might be to say I'm going to take the radius of the small circle over the height, the radius of the small cylinder over the height of the small cylinder equals the radius of the large cylinder over the height of the large cylinder. Okay, now both of these are going to end up working out the same. If I cross multiply here, you'll notice that I'm going to end up getting 12 times 4 is 48 on this side, and 6 times 8 is 48 on this side. Since 48 does equal 48, it would tell me that these two cylinders are similar. If you're looking at the green example, right, where we used the same cylinder, we just used the radius and the height of the same cylinder. 12 times 4 is 48. 8 times 6 is 48. Again, 48 equals 48. And so that would tell me that these two cylinders are similar. So remember, you don't necessarily have to do both of these. Either one of them would work. And there are other ways that you could set up these ratios as well. But those might be two of the more common ways that you might set up to try to figure it out. Now, if these two numbers are not the same, then these two are not similar. So for example, had this been a 10, so this were a 10 over 12 instead of a 8 over 12, you'd end up getting the 48 here, but then 6 times 10 would give you 60. 48 does not equal 60, so if this were a 10, these two cylinders would not be similar. All right, so that's one way that you'll see a problem using similar solids. Another way you might get it, and here we have rectangular prisms, is you want to find the missing value. And so this is, depending on how you're looking at it, kind of the width of the base. And so a couple of ways that you could set this up. One is you could take the smaller, or let's take this, the depth of the smaller prism. So, I mean, if you're calling this length and this width and that height, and this would be the length, would be that 4, and so this 12 would be the length of the larger one, equals the width here and the width of the larger one, right? And then from there, what I could do is cross multiply. This ends up becoming 84 equals 12x. And then you would divide both sides by 12. And I'm going to keep it the same color because I'm going to use it. Right? Divide both sides by 12, and you end up getting x equals 7. So I would know that, and I'm sorry, my handwriting down there is very bad. So I now know that the 7 centimeters for this length. Another way that you might solve this would be if I want to take this length over, let's say, over the 3. So I would go x over 3 from the smaller prism. And now I'm going to go, since I'm going x over 3, I got to go 21 over 9. So I now end up with, this would be 9x on this side, and this would be 63 on this side. And then I divide 9 to both sides, and I end up with x equals 7. So that'd be another way that you might get to 7. And then one last way, and this way doesn't always work, so I don't want you to fall in love with this, but if you go from here to here, or I guess let's go the other way, to go from 4 to 12, I multiply by 3. To get from 3 to 9, I would multiply by 3. So the question is, what number would I have to multiply to 3 to get to 21? And I know that 7 times 3 would give me 21. So that's another way that you could figure out the missing value. All right, so that's all we got for you today on similar solids. Thanks very much for watching the video. Don't forget to do the problems on the bottom of the page. I'll see you in class.